All right, so today we're going to talk about um, functions, inverse functions, and radical review. So this first part is a warm-up. It says the tables below list the inputs and outputs for two relations. Explain whether each relation is a function. So you could pause the video and do the problem and then unpause to check your work. So remember, when we're trying to determine something's a function, we look to see if every input has exactly one output. So for this first one, our inputs have all one output. So even though the 1 is 8 and 3 is 8, those are different input values. So yes, this is a function. Every input value has exactly one output value. For the next one, if we look to see if this one's a function, we would say no, because the input of 10 has two output values. So the input of 10 has two output values. Use the vertical line test to determine whether each graph represents a function. So we can see here, this is not a function. It doesn't pass the vertical line test. This one over here, if we were to take that line and move it across our graph, we would see that if we move this, that it does pass the vertical line test. It only hits in one spot, so this is a function. For this one over here, we can see it fails right there, pass, pass, fail. So that one's also not a function. So this one's not a function like the first one, sorry. That last one was a function. This one is not a function. So inverse function, a function f is 1 to 1 if every output corresponds to exactly one input. So notice that this is the opposite of what a function is. So we're saying every output corresponds to exactly one input. So in order for a function to be 1 to 1, it must pass the vertical and horizontal line test. For horizontal line test, the function is 1 to 1 if and only if no horizontal line intersects the graph of f more than once. So go ahead and looking at this first one, A, we want to decide if this is 1 to 1 and how do we know? So for this one here, you can see that this passes the horizontal line test. So every input has one output. However, the original graph does not pass the vertical line test. So it says, is the function 1 to 1? This isn't a function. So no, it can't be 1 to 1 because the original graph is not a function. The given graph doesn't pass the vertical line test, so is not a function. For the next one, this graph passes a vertical line test, so this is a function. And so now we want to figure out if this is 1 to 1 to see if the inverse is a function. So does this pass the horizontal line test? Yes. So this is a 1 to 1 function. Every output corresponds to one input. So yes, this graph passes. So the graph is a function. So the given graph is a function. It passes the vertical line test and passes the horizontal line test. So it is 1 to 1. So why do we use the horizontal line test? You might be curious. So the horizontal line test tells us whether or not the inverse is going to be a function. So that's how we determine. So by this right here, I would say if I were to graph the inverse, it would pass the vertical line test and therefore be a function. So for the next one over here, this one is not going to be 1 to 1. It fails the horizontal line test. Also, it fails. You can see right here the vertical line test, so no. Looking at the next one, for this graph, this is a function. So if we want to see if the inverse is a function, we can see right away that it's not because it fails the horizontal line test. So this is not one-to-one. So next one, say determine if each graph below is a function, then determine if the graph of the inverse is a function, and is the graph one-to-one. So again, go ahead and pause the video and do these 3 problems, or actually I should say 6 problems when you're done on pause, and we'll go over them. So looking at this first one, we can see that this graph here, is this graph a function? Yes. The graph is the function because it passes the vertical line test. For the next one, is the inverse a function? No, it fails the horizontal line test. And is the graph one-to-one? No, because again, it fails the horizontal line test. For the next one, is this graph a function? No, it fails the vertical line test. Is the inverse a function? So for this one, we could say that if we were to just graph the inverse, yes, it would be a function because this passes the horizontal line test. So the inverse is a function, passes the horizontal line test. But because it fails to be a function in the first place, it's not one-to-one. For the next one, this is a function. It passes the vertical line test. The inverse passes the horizontal line test, so that means the inverse would be a function. And so for one-to-one function has to pass both. So therefore, is this a one-to-one function? Yes. And so remember that one-to-one function, a function is one-to-one if every output corresponds to exactly one input. So then looking here, is this a function? No, fails the vertical line test. Is the inverse a function? No, fails the horizontal line test. And so this is not one-to-one. For the next one, is this a function? If you look right here, these are both closed circles. So because of that, this is not a function. And also, if it's a horizontal line, it's not going to pass the horizontal line test. And so it's not going to be one-to-one. Over here, is this a function? Yes, it passes the vertical line test. Is the inverse a function? So even though right here, it looks like it's starting to get kind of like a horizontal line, this looks like an exponential function, so that means it is slowly decreasing and getting closer and closer to 0 without touching or crossing over. So I would say yes, this passes the horizontal line test, and so then yes, this is a one-to-one function. All right, so that is it for our one-to-one functions using the horizontal line test and the vertical line test. So again, remember, if every output corresponds to one and only one input, then it is a one-to-one. So now let's go ahead and look again writing inverse functions. Remember, we talked about this the other day. Steps for writing the inverse function: replace f of x notation with y equals, switch the x and y variables, solve for y, and if the inverse is a function, we use that inverse function notation. But you only use this if the inverse is a function. So for here, f of x, we'll replace that with y equals, and then we have 5x minus 15. So remember, we talked about this the other day. You want to switch the x and the y's, and then you solve using PEMDAS going backwards. So solve using PEMDAS backwards. So we do things added or subtracted, multiplied, divided, exponents, and then parentheses. We don't have any exponents or parentheses here to worry about. So we're going to add that 15 to the other side. Those are not like terms. So this would be x plus 15 equals 5y. Divide by the 5. And because this is linear, we're going to write this in our slope-intercept form. So y is equal to x over 5 plus 15 divided by 5. So this would give us y is equal to x over 5 plus 3. And then we can write this as an inverse notation because linear functions pass the horizontal and vertical line tests. So therefore, you can use inverse function notation. So the inverse is equal to, you can write x over 5 or 1/5 x, it's the same thing, plus 3. So why don't you go ahead and pause the video and see if you can do 1 and it was supposed to say 2 and 3, but it says 1 and 3, but that's okay. So let's just say 1 and 2 here. Go ahead and do problems 1 and 2. So again, when you're doing this problem here, make this y equals, switch your x and your y's. Oops. And then subtract the 20. Divide by 6. And so we have y is equal to 1/6x minus 20 over 6, which is 10/3. So we can write this, because it's linear, as an inverse function notation. So this would be 1/6x minus 10/3 when we reduce. Same thing, do this problem, pause the video, and then on pause to check your work. So we have y is equal to -1/2 x plus 13. So then this becomes x equals -1/2 y plus 13. Subtract 13. We have x minus 13 equals -1/2 y. And so now this one's slightly different because we have -1/2 y. So we can multiply both sides by -2/1. Just flip that fraction if you want to think about that way. Really just multiplying by -2, but if it helps you to write -2/1, that's fine. So if I multiply both sides by -2/1 or -2, that means here I have to make sure to distribute this to both these terms here. So this would be -2x plus 26 equals y. And then I can use that inverse notation. F inverse of x is equal to -2x plus 26. And the reason, again, we can use the inverse notation is because we know that a linear function is going to pass the horizontal and the vertical line test. And then we have some review of square roots from Math 2. So rewrite as an equivalent expression. So remember, if you have a square root, you're looking for groups of 2. So if I break this down, the square root of 56 breaks down into 2 times 28. And then you can break this down again to 2 and 14. And this can break down into 2 and 7. Of course, you could break this down other ways, but this is just one way you can break it down. And then you look for groups of 2 to take out of the radicals. So this makes a group of 2, but this one and this one don't. So anything that makes a group of 2, we put as 1 and goes on the outside. Things that don't make a group of 2 go underneath the radical. So 2 times 7 would stay underneath. So this would be 2 square root of 14. So that would be my simplified answer. Same thing on question B here. So if we make a factor tree and we know 5 goes into 375, 75 times 5 times 75 is 375. And then we break that down again with 5 and 15. And then that breaks down again into 5 times 3. So again, this is a square root, so we're looking for groups of 2. So this means that 5 goes on the outside. What doesn't make a group? The 5 and the 3. So times 5 times 3 underneath the radical. So 5 root 15 would be my simplified radical answer. And we don't have an example like this on here, but let's say we had like the cube root of 8 or something like that. So if you have a cube root, instead of looking for groups of 2, you're looking for groups of 3. So this would be 2 times 4 and 2 times 2. So this makes a group of 3. So the cube root of 8 is actually equal to 2. And so if we had a fourth root of something, we would look for groups of 4. Fifth root, we would look for groups of 5. So now let's look at some with variables. So here, if we wanted to simplify this, we know that 9 breaks down into 3 times 3, and x breaks down into x times x. So if we have that, then that means this is equal to 3x. Then for the next one, we could do the same thing. So here we have 112. So that breaks down into 2 and 56, which breaks down into 2 and 28, which breaks down into 2 and 14, which breaks down into 2 and 7. So we have this group here and this group here, but then this doesn't make a group. So on the if you multiple groups, you just multiply them. So that'd be 2 times 2 on the outside times the square root of 7. And then we have x to the 14th. So we're trying to think about how many of these do we have? So if we write them out, how many groups of 2? So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You can see you have 1, 2, 3, 4, 5, 6, 7. So that means we can take 7 of these out. So really this would be 2 times 2, which is 4. And then x to the 7th power times the square root of 7. Another thing you can do is you don't want to have to write out all the x's because that can be quite a lot of work. You can think about, well, this is an index of 2. So how many times does 2 go into 14? 7 times. So that's why we have 7 groups of 2x's. All right, so then for the next one, 24. 24 breaks down into 2 and 12, then 2 and 6, and 2 and 3. So this makes a group, and these don't. And then let's look at the x's. So instead of writing them out, let's think about if we have x 6th power, we're trying to think how many times does 2 go into that 6? Well, it goes 3 times, so that means x to the cube. Because really this is 1, 2, 3, 4, 5, 6. So we would have 3 groups. We have y to the 4th power, divide that by 2, that's y squared, which makes sense because we would have 1, 2, 3, 4. So 2 groups of y. And then the z doesn't make a group, so that's going to stay underneath. So we have 2 times 2 on the outside, and then we have times x cubed and y squared, and then underneath the radical, the 2 times the 3 that didn't make a group, and then we have that z as well that also didn't make a group. So 4x cubed y squared times 6z. And so that would be all for our radical review. So then you have the rest of the time to work on your homework.